The overall goal of this experiment is to demonstrate that dynamic light scattering and confocal microscopy can be used to measure particle size distribution in turbid solutions without dilution.
The main advantage of this technique is that it can measure particle size distributions in concentrated solution and help answer questions in polymer and colloid science.
To achieve this goal, we developed the apparatus to measure dynamic light scattering under a microscope.
This is the setup for the dynamic light scattering microscope. It has a solid-state laser capable of 30 milliwatts continuous wave operation at 488 nanometers. There is also an avalanche photodiode and autocorrelator connected to a computer for measurements. The inverted microscope in the setup has a stage with a temperature regulator. The box contains the remaining optical elements required for the experiment. This schematic provides a more complete view of the layout for the setup. After shaping the beam profile, the beam is introduced into the microscope. Light scattering is obtained with a backscattering geometry and guided to a detector. A launch mirror allows some reflected light to be observed via a CCD camera. The samples for the experiment must be prepared a day ahead. Sample preparation requires 20 milliliters of degassed, deionized water, as well as purified NIPA. In addition, it requires small quantities of TMEDA and ammonium persulfate. The preparation steps also make use of an ice water bath on a stirrer, 2 reaction vessels, aluminum foil, and a source of argon.